This one I'm supposed to use differentials to estimate the value of the square root of 23. So what I need to start with is figure out a square root that's close to 23 that I know. And I know that the square root of 25 is equal to 5. And now I look at how far off 23 is from the 25, and that is it's minus 2. And that what that becomes is my delta x. Now you should be able to identify what function we use for each of these. But for this one, and this is probably the type that we've done the most, the square root ones, I'm looking at y equals square root x. And I can derive this with respect to x and get dy dx equals, and you should be able to work this out, but I'm not going to show the work. We do it a lot. You should get 1 over 2 root x. Comes from power rule. So now what I do is, instead of looking at d's and or dy and dx, I look at delta y, and I'm going to actually multiply by this piece right here and get a, I'll write it on the end, delta x, and then I get I get a delta x, and then in the bottom I get my 2 root x. So basically I multiplied by this and it showed up here. And this is an approximation. So now that I know my approximate delta y, I can take these values that I know that x is 25, so that goes in here, and I know that delta x is negative 2, so that goes in here. So my delta y is approximately this, which is then equal to, I'll go back to black, minus 2 over 2 root 25, which is minus 2, actually, these guys cancel, give me 1 over, that's a negative 1, root 25 is 5. So what I then do, I'm calculating an approximation for this thing, and I'm using this guy. My delta x was this, so I drop this delta y from this y value right here. So my answer would be take that 5 and subtract 1/5. And you could leave it like this, or you could simplify it to whatever that winds up being, but I'm totally fine if you leave it like this.